Now today in this video lecture, explain the congestion control. Now congestion control is very important feature of network layer. In congestion control means congestion is said to occur in network when resources demand exceed the capacity and packet are lost due to too much queuing in the network. Now, definition: be too many packets are present in the subnet, performance degrades. This situation is called congestion. सपोज किसी एक पर्टिकुलर पॉइंट की कैपेसिटी से ज्यादा उस पे रिक्वेस्ट की जा रही हो, उसको यूटिलाइज किया जा रहा हो, तो एक पॉइंट की सिचुएशन को बोलते हैं कंजेशन. When router are receiving packet faster than can forward, one of two things must happen. First, suppose subnet must prevent additional packet from entering the congested region until those already present can be processed. This is the first point. And now second point, the reason up. The congested router can discard queue packets to make room for those that are arriving. This is the two main things must happen during the receiving packet faster than can be forwarded. Them one, two things. And during the congestion, the network throughput may drop to zero and path delay may become very high. This is the property of congestion. So, the congestion control explained with this diagram. Suppose that x-axis show the packet sends, y-axis show the packet delivery. If packet sent and packet delivery, the capacity of packet sent and packet delivery, capacity of packet delivery is same, then we find a linear line. Now, at a point, more than packet sent with their capacity of network, then situation is created congestion. After created the congestion, several number of packets is blocked and performance degraded. Like that. This situation is known as a congestion. So here discuss some point. What is the difference between congestion control and flow control? So congestion control is needed when buffer in packet switches overflow or congest. So congestion control is needed when buffer in packet switches overflow or congest. While flow control is needed when the buffer at the receiver are not duplicated as fast as data arrives. Next point. Congestion is the end-to-end. It includes all host, link, and router. While the flow control is between one data sender and one receiver, it can be done on link or end-to-end basis. And third point, if viewed as a congested buffer, then their switch tells the source of the data stream to slow down using the congestion control notification. When the output buffer at the switch fill up and packet drop, this lead to congestion control. While in the flow control, if there is a queue on the input side of the switch and link by link flow control is used, then flow control action, the switch tells the immediate neighbors to slow down if the input queue fills up. This is the basic difference between congestion control and flow control. So general principles are used for congestion control like that. First is open loop solution. So with the help of open loop solution, solve problem by good design, in essence to make sure it does not occur in the first place. Once the system is up and running, course corrections are not made. So tool for doing open loop control include deciding when to accept new traffic, deciding when to discard packets and which ones, and making scheduling decision at various points in the network. Now next is closed solution. In closed loop solution, monitor the system to detect when and where congestion is occurring. Suppose matrix for congestion measurement for router post percentage of all packet discarded for lack of buffer space, the average queue length, the number of retransmitted packets, the average packet delay, and the standard deviation of packet delay. So we can also send probe packet out periodically to explicitly ask about the congestion. This is the point of closed loop solution. Now next, closed loop solution like that pass this information to places where action can be taken. It means the obvious way is for the router detecting the congestion to send a packet to the traffic source or source announcing the problem. So of course, this extra packet increase the load at the precisely and the moment that load is not needed. So a router can set bit in the packet to notify neighbors when congestion occurs. This second is closed loop solution, and third adjacent system operation to correct the problem. The hope is that the knowledge of the congestion will cause the source to take appropriate action to reduce the congestion. To work correctly, the time scale must be adjusted carefully and react to quickly. System will oscillate, react to slowly, no real issues. The third process. Now next, some techniques used for the congestion control are explained like choke packet congestion control. In the choke packet congestion control, suppose that this is so the routers host send the message. Several number of routers are connected in this network. Suppose that a particular point in the router received number of packet from maximum or exceeding the number of packets. Suppose that the capacity of router is less with respect to receiving of packet. So here the threshold, here the congestion situation is created. So router is created a choke packet, and these choke packets sent to the host because and inform the host if these are situation created in congestion. So slow down there the sending, slow down the process of sending packet. Now, and the next tag packet also generated by this router. The tag packet send the next hop router because that inform he this router is already sent a choke packet because सभी routers क्या choke packet send करेंगे तो choke packet की वजह से congestion create होगा. So this tag packet inform the next hop router if that router already sent a choke packet to the host. So tag packet to prevent further choke packet generation at later the router. This is the process of choke packet congestion control. So congestion prevention policy, some congestion prevention policy like transport layer policy in layer of transport layer, retransmission policy, out of order, catching policy, acknowledgement policy, flow control policy, timeout determination. This policy are used in transport layer of Versailles model. Virtual circuit versus datagram inside the subnet packet queuing and service policies, packet discard policy, routing algorithm, packet lifetime management, that policy are used in the network layer of Versailles model. Retransmission policy, out of order catching policy, acknowledgement policy, and flow control policy is the policies under the data link layer of Versailles model. So now next we explain the concept of traffic stack. A source promises the network that the traffic is flow sent into the network will conform to a particular share. Suppose that the network use this information to like that decide whether to accept the flow. CAC means connection admission control. If accepted, how to manage the flow traffic? UPC uses parameter control. So these three major purposes like that. The network knows what kind of traffic to expect. Second, the network can determine if the flow should be allowed to send. And next, the network can periodically monitor the flow traffic and confirm that flow behavior as it promised. That is three major proposals. So traffic shaping is about regulating the average rate and first stiffness of data transmission. In contrast, the sliding window protocol. We studied earlier limit of the amount of data transmit once, not rate which is set. So monitoring of traffic flow of all traffic policies and good traffic shaping methods should be easy to policies. For example, leaky bucket algorithm used for the congestion control. अब इसे leaky bucket क्यों कहते हैं? Suppose that bucket या buffer work like that a bucket, leakage bucket. Suppose some water are put in this bucket, and here leakage water in form of drop from this water. This is the leaky bucket. Any buffer is known as leaky bucket. Water drop out the hole at a constant rate. This all concept work like that a bucket, leakage bucket. So it is known as leaky bucket algorithm. According to leaky bucket algorithm, host computer are send the packet to the network. If packet are send the host in unregulated flow form, these packets are stored or hold by the bucket and interface. These bucket or buffer are work as an intermediary between host computer and network. These buffer are stored in this bucket, and these buffer transmit the packet per tick in regular way. This is known as leaky bucket. But disadvantage of the leaky bucket algorithm because एक कांस्टेंट रेट में ही यहाँ पे अगर बहुत ज्यादा ओवरफ्लो हो जाएंगी, अब नंबर ऑफ पैकेट बहुत ज्यादा है, तो दैट पैकेट इज ओवरफ्लो या डिस्कार्ड बाय द बफर या बकेट. But here only one packet is sent to network in per tick. So speed and efficiency is slow by using the leaky bucket. So we allow token bucket algorithm. Some modification, we use the token bucket instead of the bucket. Same algorithm like that, host computer send packet, and this buffer is work as an intermediary between host computer to networks, and unregulated packet are stored in this bucket, and each token collects several number of packets, and these tokens travel from this buffer to network a constant rate. So number of packet, several number of packet are stored in a token, so speed and efficiency increases with respect to leaky bucket algorithm, because one token is added to the bucket every 30 times. So traffic saving, calculating the length of maximum rate bus like that. Bus length is capital S seconds. Token bucket capacity C bytes, capital C bytes. Token arrival rate rho byte per second. Maximum output rate equal to M byte per second. So we can say that C plus rho S equal to MS. Yeah, capital S equal to C by M minus rho. Token bucket will leaky bucket rate control like that. Limit how long the token bucket can monopolize the network. So limit the size token bucket, size to restrictive. Token bucket combined with the simple leaky buckets. Data transfer token are stored here, and C should be substantially greater faster than rho, the maximum transmission rate at any time in C. For example, a computer on 6, for example, a computer on 6 megabit per second network is regulated by a token bucket. The token bucket is filled at a rate of 1 megabit per second. It is initially filled the capacity with 8 megabit. How long can be computer transmit at the filled 6 megabit per second? Or according to the concept of traffic shaping, capital C equal to 8 bit capacity, M equal to 6 megabit per second, rho equal to 1 megabit. According to the formula, S equal to Cm1m minus rho, apply and find the computer can transmit up to 1.6 seconds. So basic difference between leaky bucket and token bucket. Leaky bucket discard packet, while token bucket discard token. Leaky bucket packet can be transmitted if packet is not full. Token bucket, in token bucket, packet can be only transmitted if there are enough token to cover its length in bytes. Leaky bucket send packet in average rate, while the token bucket allow the large bus to send faster, speeding up to out. Leaky bucket does not allow saving the constant rate is maintained, while the token bucket allows saving of token to send large bursts. This is the basic difference. And next, flow specification. So traffic shaping is most effective when the sender, receive, and subnet all agree to it. So to get agreement, it is necessary to specify the traffic pattern in precise way, such as agreement called the flow specification. Again, explain. If traffic shaping is most effective when the sender and receiver and subnet all agree to it, to get the agreement, it is necessary to specify the traffic pattern in a precise way, such as an agreement is called the flow specification. So before connection is the established, or before a sequence of datagrams are sent, the source gives the flow specification to the subnet for approval. The subnet can either accept it, reject it, or come back with counter proposal. So flow specification, some characteristic of the input and service desired like that. Maximum packet size bytes, loss and sensitivity bytes. Token bucket rate byte per second, loss interval milliseconds. Token bucket size B bytes, burst loss in T packet. Maximum transmission rate, minimum delay notice. And jitter maximum delay, jitter equal to maximum delay variation millisecond. So this is the flow specification.